Hello and welcome to our new and exciting CADclips series on REVIT Structure I'm calling A to Z. And this lesson is an overview of what's to come in this REVIT Structure series of CADclips. What I'm going to do is I've got some notes and stuff inside of here, and I'm going to kind of fire through this and give you a bit of a heads up on the different things that we'll be learning in this series of CADclips, and then I will flip over to a 3D model and give you a bit of a demonstration on some of the features of REVIT Structure. So first thing I want to mention is that these CADclips, or this series, is designed for the new REVIT user, new to REVIT or REVIT Structure. Either way, we're going to go over, treat this like you've never used REVIT as a product right from the beginning. So the next note I want to make in here is these CADclips will be using REVIT Structure 4, and unfortunately this is right on the doorstep of REVIT Structure 2008 being released, and I can't do too much about Autodesk's release dates, but the main thing is I have been told by a very reliable resource that the difference between the two, REVIT Structure 4 and Structure 2008, is very minimal, especially in the fundamentals, virtually no change. So if you're viewing these REVIT Structure CADclips in Structure 4 and you're using 2008 version, not to worry, you can just kind of go through it. So the next thing I want to mention is please feel free as I develop these CADclips to suggest a topic before the series is done. You can email me at cadclips@telus.net and suggest a topic. Maybe you've already been using REVIT Structure and you've already got something you want to know. By all means, send me an email. Now, the next thing I want to talk about is using REVIT Structure in a nutshell. Okay, right here. And what I want to mention here is really, in a nutshell, what is REVIT Structure? Well, it's using the REVIT modeling and interface tools. So we have all the nice interface tools that we have with REVIT, and we use that, be it as an architectural tool or as a structural tool. We're going to learn all of that and all the modeling techniques and stuff like that. And then on top of that, we're going to use the REVIT structural modeling tools themselves. We're going to use the REVIT structural analysis schematic model. We're going to create and apply structural loads. We're going to learn about checking the structural member connectivity and integrity. And then we're also going to learn how you can integrate with a third-party structural analysis program. So at a glance, this is really, this top paragraph here is what using REVIT Structure is in a nutshell. So given some more detail on what we're going to cover in these particular CADclips, and I use the word some of the things we will learn over the course of these REVIT Structure A to Z CADclips, because obviously we're going to learn a lot more than what I've just got listed here, but this is really the bulk of it. So we are going to talk about the interface of REVIT using the pull down menus, the design bar, the toolbars, the options bar, status bar, the type selector, the project browser, view control, and view control bar, and the drawing area. So we've got, you know, all of our pull down menus, we've got all of our toolbars, we've got our project browser, we've got our design bar over here. Down on the bottom we've got our view control bar, and then we've got our general drawing area. So we're going to learn all about this. Obviously we're going to be using the interface throughout the entire series. Again, typical for REVIT Structure or architecture. We're going to talk extensively about settings. Specifically, we're going to talk about the structural settings and how our load cases work, which is all the good engineering stuff, and load combinations, analytical information, boundary connections, and stuff like that we're going to have a look at. So all the settings, as well as all the other settings with line styles and line weights and view tags and annotation settings and project units and all that good stuff. So we're going to learn all about the settings, and we're going to talk about grids and levels and reference planes, our main datum objects. And grids are fantastic as well are levels. That's our parametric power. If we move a grid, then all the columns and beams and walls that are associated to that grid will update. So at a very quick snap of the fingers or click of the mouse, we can move a grid line or change a dimension between a grid line, and the whole entire Revit model will update, including the sections, the elevations, and the plans, and all that stuff. So normally, heaven forbid, someone moves a grid line. Well, that's a big job in traditional CAD drafting, where you've got to update a lot of stuff when one grid line moves, even if it's just a couple inches or a few millimeters. So in Revit, you move the grid line and that's it. Revit just pieces it all back together and stretches it all around. Similarly with levels. With levels, we move a level up or down, or we change a level elevation. Okay, levels are horizontal planes that are offset vertically, and the levels control our model. Everything is associated to a level. We've got top of footing, underside of underside of slab, or top of slab, or second floor, third floor, 10th floor, whatever you want to name your levels. You move a level, everything on that level or associated. You can even offset things from a level. Something can be 4 inches above a level or 6 inches below a level. If you move the level, everything tied to that level will then move. Reference planes, another form of datum, and we can work with our reference planes as well. Okay, a must, I say. Grids, levels, reference plane are all a must when we're modeling, be it Revit Structure or Revit Architecture. We have general modeling tools as our next topic, and general modeling tools are, everything I know about modeling, and that is, whatever I've learned in the last couple of years about modeling in Revit. I'm going to teach you all that great stuff. So modeling techniques all over the place by using, all of our different components and everything that we could possibly do. So this is really a big topic of general modeling. Okay, copy and paste. Revit takes full advantage of the copy and paste technology, whereby we can copy a floor or a level and then paste it, up the next 10 levels, and all of a sudden we've got an instant high rise with, all of our typical floors with all the openings and columns and everything will just get pasted up. So instantly you can take, especially if you have typical floor plans, you can very quickly copy and paste those up and create that great big beautiful 3D model. And you can copy and paste from project to project and some really neat stuff. So copy and paste we'll be doing extensively. Taking a lot of shortcuts with this technology. Views, we've got section views, we've got callouts, we've got cameras, we've got walkthroughs, plan regions, elevations, all this good stuff under our views topic. We're going to learn all about these and how we can then take all our views and add annotations and scale, put a scale factor and put these on our sheets, and we can duplicate views and do all kinds of neat stuff with views. So views are really one of the magical things about Revit, and we're going to be using those and learning all about this extensively. We've got a few more tools. We've got the line work tool, match type tool, paint tools, and our tools are all up inside of here: align and split and trim and offset and different attached join geometry and join roofs and all of our great tools. We've got our options bar over here, which is dynamically changing all the time. If we go in and draw a beam, we'll see that we have different beam options. If we draw a column, we'll have different column options. So the options bar and toolbar is always changing depending, or I should say the options bar is always changing. The toolbars are static, reference planes and stuff. So line work and match type and painting materials and stuff. We're going to learn all about those. Then we get to our documentation topic, and once we model it all, we need to add our text notes and our dimensions and our schedules and title blocks and reference planes and bubbles and keynotes and tags and legends. So we add all of our documentation to our objects, and then on our views, and then we take those views and we put them on a sheet. We'll talk about printing, all about printing. Printing in Revit's really easy. It's pretty basic stuff. We can learn about that, adding materials and creating and managing materials. Materials are kind of neat, where we can get in and do some shading and rendering and do some perspective views and make things look realistic. And and also use materials as far as keynotes go. Then we can talk a little bit, we'll learn about visibility graphics and view templates. Okay, visibility graphics and view templates really work hand in hand. Visibility graphics are the closest thing that we have that resemble AutoCAD layers. So if you've used AutoCAD, you know about layers. Well, this is about as close to layers as you'll get in Revit. You can go in and you can have a look at, you know, the different floors and the different components of a floor, and you can turn them on and off and control the way they appear in line types and all kinds of stuff. Annotation objects, you can turn things on or off first of all, and then you can control the appearance. Imported CAD files and stuff you can control. So visibility graphics, very powerful tool, adjusting the visibility of various model and annotation objects. We'll learn about that. And then the best friend of the visibility graphics is our view templates, because we can basically capture the way the view visibility is set up per view and create a template and apply the view templates and transfer them from project to project. So view templates, there's a bunch of them that come with Revit built in, and we can change those view templates as we please and then alter them and save them and transfer them from project to project. Very powerful. Another great shortcut, view templates, working with our visibility graphics. So everything up to that point is all kind of standard Revit stuff. And then we get into the really juicy stuff, which is the structural things. So we have our structural physical model where we go in and we model our structural stuff. Columns, beams, joists, purlins and trusses and load-bearing walls and foundations and slabs and footings. We model that. As we model that, the structural and analytical model, the fun stuff, this is the structural schematic or stick frame of the physical model that is being created automatically. And then you can tweak it and go beyond the physical model. So structural physical model, structural analytical model is really the meat and potatoes of REVIT Structure, where we can model and then look at it, and it's all color-coded line work. So beams are one color and columns are another color, load-bearing walls are another color, and then we can take those and look at them in different visibility states, just like as if you were looking at it as a third-party structural analysis program. And then we can have a look, and we will look at that as soon as I'm done all of this tech stuff here. We'll have a look at the model. Okay, we have boundary conditions, fixed and pinned and roller and user-defined conditions. We have loads. Okay, loads is once we model it and we have a look at our stick frame analytical model, then we can go in and we can create case loads for live loads and dead loads and wind loads and snow loads and seismic and all kinds of great stuff. We can use combination loads of everything above. So then we can take these loads and graphically apply them to our model. And it shows us a little diagram of the different loads, be it a linear or an area load or a distributed load, all the fun engineering stuff. Okay, and we take those loads that we have defined as live and dead loads. We can factor those loads, of course, and then we can apply them to our model. Fantastic. Then we go to our analytical support and our third-party analytical integration. So we then take our analytical model in Revit and we say, okay, show me the integrity and the connection connectivity of all my structural members, and Revit will point out to you whether there's a miss between the connections. It'll say, oh, there's a missing footing here, or there's, you know, a beam that's being held up by a sky hook, or there's a, you know, a column that's got a problem. So it'll point out the problem areas with our analytical support check, and then it'll zoom us to that part of the model, and then we can just fix it and change some offsets and do some neat stuff with that. So then after we do all that, we then prepare it and we export our analytical model or our structural model to a third-party analytical software. So third-party analytical integration, yes, you can export the structural model to one of 3 structural analysis programs, and then that will analyze it outside of Revit, and then you import it back into Revit, And what it will do is it'll make the changes in the, if you make changes in the analytical software, the third-party software, you bring it back into Revit, it actually shows you where the changes have taken place and where the problem areas are. And then the extent of that lesson I have a to be announced because we'll see how far we get with getting that third-party analysis software installed and running. So that's all the good Revit structural stuff. And then of course we can import and export views or sheets to a DWG or DGN. So we can actually take our Revit 3D model and export it to architectural desktop, and it actually, I think it's easier to model it, a structural model in Revit, and then export it to architectural desktop in full 3D with all the columns and beams and joists. It turns out better than if you actually try to model it in ADT. So if someone wants a 2D flat file of one of your floor plans or framing plans or your shear walls or whatever you want, you can export either the whole sheet or just one view of your Revit model to a DWG or DGN, and you can likewise import them. If someone gives you a 2D flat file of an architectural drawing, you can use that DWG file or DGN, bring it into Revit, and then very quickly trace over top or even snap to the imported objects and very quickly get your Revit structural model up and running from that imported file. We're going to talk about families. Families are very much like blocks in AutoCAD, but much more sophisticated, of course, and we'll use them and we'll create some custom families, and we'll do some general work and management and copy and paste and moving from project to project and all kinds of neat family stuff, family types. We'll talk about stairs and learn about modeling stairs in 3D and creating multi-level stairs, and much more as the lessons start to develop. So combined with perhaps some of your suggestions and or these topics I've just covered, we'll be filling in the cracks with all kinds of other little stuff. Obviously I can't verbally and written cover everything we'll do, but this is really a good chunk of what we'll be doing. And I just have a note at the bottom here for roofs and phasing and work sets and custom families. I will refer you to our CADclips.com webpage, where we have some extensive lessons already created on those particular topics, and I don't really want to repeat them because they're still perfectly valid and they were done quite well and I've had good feedback. So we will be doing some roofs and some custom families, but for the most part, if you want more detail on roofs specifically and phasing and work sets and custom families, have a look at our CADclips.com on the left hand side where the Revit is, and we have more lessons on there. So now I've just zoomed in here, and all this is a bunch of text in my Revit model. I'll just have a quick look at my 3D model here, and I've just got a little bit of a teaser here, and I've just got a 3D model. I'm just demonstrating how you can take a slope beam and tie a beam system. Okay, this is a beam system, all these guys, and tie it to this beam, and then if you slope this beam, the whole beam system will then slope with it. And you can see that I need to fix my offsets on there, but just as an example, okay, I can click on this beam system and I can go into the properties of it, and I can say, okay, it's not a W8, it's an actual open web steel joist, and it'll change all those in that beam system to be open web steel joist, and it'll update the model for me. And then it'll turn those into joists, which is quite nice, and I can see there's a problem with this guy inside of here. Need to fix the offset of that guy. I'm going to go back into here and say, oh, that's, I don't know why that one I've been playing a little bit should be only a 4-inch offset, so I can fix that one up there. Okay, I can also take this particular beam and go in and have a look at this and say, you know, there's a 4-foot offset. Well, if I bring this down to maybe, you know, bring it down another 2 feet and say it's only 8-foot offset from level 2, that will slope, and then we'll also see my beam system and all my joists will slope on top of that. Will fix themselves up, and you can see that my generation, I think my recording software is also slowing me down here a little bit. And we can see there my beam got dropped down, not necessarily a ideal scenario, but fair enough, my joists have, because they're tied, that beam system is tied to this spandrel beam over here on the outside. All my joists are going to slope with it. So there's just an example, an extreme example, I should say, of how that works. And then I'd have to tidy up this corner in here, okay? So then I've got some foundation walls, I've got some footings, a few columns, another beam system again over here. And you can see, you can click on that beam system anytime, structural beam system. I can go in there and say, okay, you know, W8s instead, and it'll switch that up. So you can very quickly go in and do this. This is just a tip of the iceberg of the power of what you can do with Revit. And then of course I can change my visibility to say wireframe, and now I can kind of transparently see. You can see the blue column, that's the analytical model. The tan, the light line, is a beam, and then the green lines are load bearing walls, and you know, so everything's color coded. And I can switch over here and say course detail, and now all I'm seeing is the actual analytical model in the background, which is quite nice. And the engineers like this. It starts to resemble the actual third-party structural analysis program. So we can flip between, and it depends if I'm looking at level 1, or I can zoom in, I can look at level 2. Okay, as I look at level 2, I can switch between different medium detail. It's going to show me more detail. I can show fine detail. It might show me more, it might not, depending on what I've got modeled. Okay, go back to being coarse detail. I can go to medium detail and shaded, or I can go wireframe, okay, or I can go hidden line, or I can go shaded, and then, you know, so we can play with our different visibility, and this just happens to be level 2. If I go to level 2 analytical, level 2 analytical looks like this, and inside of here, once again, we can look at different detail levels and different shaded views and stuff, and we'll have a look at that. Now, analytical specifically is designed not to show the physical model. It's there only to show the analytical model, which we can see there's a column which is blue, and there's our beams. Okay, back to level 2. Well, level 2 is an analytical view. It's a regular physical view, and it's designed to be that way. We can see it's got all our gray tags and stuff on there. So this is, again, just a little bit of a tip of the iceberg of what we can do with our Revit structure.